So here's this quote from AP, meaning you'll see this on the AP exam. So the inverse of a trig function x may be indicated using the regular notation that we've seen, or arc. Have you guys dealt with arc before?
Yeah.
Okay. So being able to use both, and feel free, absolutely, like if you look down here at number 3, feel free to just rewrite it as inverse secant if you don't like arc. It's fine. It's nice that it tells you that though. All right, so first thing I want you to notice is there's some patterning in this table. So that's in an effort to help you memorize these maybe a little bit better. But it is still, at the end of the day, something that you're going to have to memorize. So first thing I want you to notice is all these left ones have, well, the first two have an S, and then we have tangents. And you're going to see similarities between those that kind of, you can use some of the letter references to help you. So the derivative of inverse sine. Actually, before I start talking about this, what does inverse sine mean? Like if we weren't taking the derivative, if we just said like inverse sine of what has to go in here? What is our input for inverse sine?
Y.
Okay, it is y, but like what values would go in there?
Like 1 to -1.
Yeah, good. So -1 to 1 has to go in here. So let's say we did inverse sine of -1. What are we spitting out?
All of the x values for sine of x would be.
So what?
So like all the x values for sine of x.
Which is what?
Like 3 pi over 2 and then all of the.
Okay. So yes, 3 pi over 2. I don't know how much you got into this in your pre-calc, but remember that and this is what those circles are on the bottom for, but we restrict the domain for inverse trig functions. So this would actually be negative pi over 2. So up to down. It's only those values. And
Oh, I remember that. Remember like the half circles that we
Yep. Yeah. And it's because otherwise it's not a function, because our vertical line test would go. So I'll talk more about that below when we get to the circles. But just wanted to remember that for these inverse trig functions, the input is like a decimal number, and the output is an angle versus the other version. Anyway, so let's look at this first one. Anything with an S, so really it's just these two, you're going to have two things that you need to put into your derivative. All of these will have a 1 on top of a fraction, so all of them will have a numerator of 1. Anything that has an S, like I said a second ago, will have two things. It will have a square root and a subtraction sign. Okay. This one has an extra little thing, so I'm leaving room there. But first one is 1 inside the square root is 1 minus x squared. There we go. And anytime it says x, I'll write this, but I'll say it first. Any of these, where it says x, it's talking about what's inside of the inverse function. So think about if this said inverse sine of 3x minus 2 or something. That's what has to be represented in the x place. Okay? So for all x represents what's inside of the inverse trig. Okay. Next one, inside the square root, we just reverse those. So x squared minus 1. We'll come back and add that in a second. Actually, let's just do it now. This one, we have to add kind of a wonky thing. We're going to add the absolute value of x. out front. Okay. And then tangent. So S, square root, subtract. Tangent kind of looks like a plus sign. So instead of, and there is no S, so instead of square root and minus, we just have no square root and a plus sign. So again, anything with an S, a square root, and a subtraction. This one has that extra absolute value of x out front. Tangent, no S, plus sign, looks like that. Good? It's a lot to memorize, right? So just like we did with the inverse formula, practice writing these down each time. You'll see here in just a few minutes, this causes some issues with simplifying. So if you had a multiple choice question that had options that don't match this, that kind of is tricky. So we'll do some examples of how to deal with that. All right, these ones, all the C's, which, by the way, cosine, cotangent, cosecant. The co is short for complementary. Why would that be? Like, think of complementary sine, cosine. You guys remember the relationship between the sine and cosine values? They're not necessarily, but remember on the unit circle how they switch? So like at pi over 6, it's 3 square root of 3 over 2, 1/2. And then it's the same at pi over 4, and then at pi over 3, it switches. So going back to the idea of like a right triangle, let's just put in some numbers. So can you read that's a 7? And let's just call this 10. And so if I say A and B, what's the sine of A? A, right? 8 over 10, okay? And then what's the cosine of B? 8 over 10. So those are complementary angles, those two, right? So that's kind of where that comes from. Anyway, any of the ones, just like we saw before, by the way. I don't know if you remember, but when we did the derivative of cosine, cosecant, those, negative. So any of the ones with the C, you have to have that negative out front. Otherwise, it's the same, so that's nice. We don't have to re-memorize something else. So these, even though there are 6 new things to memorize, at least there's some patterns that can help us out with that. Okay? All right, so right away we see one that we're going to have to do one of these new rules, but also what? Yeah, this is the chain rule as well, because we don't just have a 3 or something inside, we have to do another function. Okay. I'll just write equals there. So derivative of the sine, or excuse me, the inverse sine. So subtract and square root. This one is 1 minus x squared. But what do we plug in for x? 3x. So you could write it out if you want. Like I said, let's just write 3x squared. And then multiplied by this. So chain rule, multiply by the derivative of the inside, which is just 3. So if we kind of simplify this a little. Okay. Can I square root those two? Okay. So be careful not to be tempted in. I could totally see AP putting that as one of the choices, right? Like 3 over 1 minus 3x. And tempt you to square root those individually. Don't fall for it. Any questions on why? Hmm?
It's the negative.
Yeah, because that is basically that square root is grouping those, so we have to do the grouping first, right? And we can't since there's an x. All right, next one. So derivative of tangent is 1 over, or sorry, I keep saying it wrong. This is inverse tangent. 1 over x squared plus 1, and then times 4x. X in this case is 2x squared. Okay, so if we simplify this, we get 4x to the 4th plus 1, and then 4x on top. Can we simplify anything there? It's tempting, right? To simplify the 4's, even the x maybe.
Good, but you have, oh wait, no.
Yeah. In this case you can't, but I know what you're thinking. Like if it was the reverse, then you could a little bit, right? If it was the reciprocal. Okay, and then we have arc. Again, if you don't like arc, you can rewrite it as just the inverse. Okay, so 1 over absolute value of 5x, and then square root of 5x squared minus 1. So subtract and square root, since there's an s there. And then times 5 out here because of the chain rule. Okay, so let's write it like this first. Just write that by squared. So 25x squared minus 1. Okay. Can we simplify anything there? Like, we have a 5 over a 5 being multiplied, so there's no issue with adding or subtracting order operation stuff. So the question is, can you simplify the 5 with the one that's in the absolute value?
Yeah, because 5 is constant. Or, right, because 5 always has the same sign. X is the only one that would be negative or positive.
Good. So it's exactly what he said. This 5 is only ever a 5. We don't have to worry about it being potentially a negative 5. So 5 over that 5 is okay to cancel. But that x, we don't know if it's negative or positive, so leave it there. Now, that's what we're going to do next. So there it fits. Any questions so far? Okay. Actually, I meant to. So this section is just simplifying practice. So like I said, to make sure that we can maybe match our solution with maybe a multiple choice option. So these I want you to think of as the derivative is already done. And we're just simplifying, okay? I better. So derivative's done. We're just looking to maybe match our solution to one of the multiple choice options. So here's how you're going to work through that. Looking at the function or the derivative, so look at what's given. Look at the derivative result and determine the sign that it will be. And you're going to want to plug in a negative x value, because who cares if it's positive? That's the same, right? If x is positive, this absolute value makes no difference. So we really just want to check a negative x value. Okay? if I plug negative x into the numerator, what sign do we get? Yeah. Oh, I would recommend just -1. You can use any negative number, but okay. So if we plug -1 in, and I'm writing a lot of notes that you don't have to do every time, right? So we get positive over what will this be? Positive. So we need to make sure this is positive. If we simplify, it needs to remain positive. So our goal is really deciding whether we put the absolute value in the result or not. Okay? So then we simplify what we can. Simplify and decide if absolute value is needed. Okay. So if we simplify this, what all can be simplified? So 9 over 3 would be 3 at the top. X squared over x cubed leaves an x down in the bottom. Leave the absolute value off for now. And then we can't touch this. Okay. So going back to plugging in a negative x, if I plug in negative x in here, this is now negative. And it's supposed to be positive. Right?
Well, you square root the positive or negative, so.
Well, we're not worried about so much this because we can't touch it, right? We didn't simplify it. So it's really just what will simplifying out here do to it. Okay? So if we plug x equals -1 in here, it's negative. So what do we need to do? Yeah. Now it's positive. Now it matches. So think about how this might look on a multiple choice. They probably would give you those, like this version, and then the one with the absolute value, and only one of them is right. So this is your check to distinguish between. And, you know, the other couple options would be something else, but likely that they're not just going to have this one, I guess is what I'm saying, right? So you'd have to do your check to make sure if you need that or not. Okay, let's try this one. So plug x equals -1 again. Top would be negative. Bottom is positive. I'll write the word positive, I guess. So this is going to be negative overall. Okay, simplify what we can. So what do we end up with there?
2 over x.
2 over x.
Square root of 4x.
Yeah. Okay. Re-plug in -1 now. So 2 over -1 is negative. Okay, so we don't need those. If you put them on there thinking that you should, then it's actually back to wrong again, right? So I bet they'll put one with those on there just to tempt you. Any questions on that? Okay. All right, this is just a reminder. It's kind of like what I was mentioning before. I don't know if you can highlight, but for sine, we just use quadrant 1 and quadrant 4 for our domain, or for our domain and range. So our values input, like we said at the top of the page, -1 to 1, but our output values are only -pi over 2 to pi over 2. Even though that is 3 pi over 2, we don't call it that. Cosine is 0 to pi for our range. So think about if, like back to geometry, probably is when you did this, maybe a little in pre-calc. You know, if you're solving for like what angle do you have to look at to see the top of the mountain or something, right? Your calculator would only spit values out in here. In fact, in most cases, it probably wouldn't even say the negative, like negative pi over 2. And then tangent, what do you think about it? Do you guys remember this at all? Okay.
Well, like normal tangent, it's like a bunch of repeating with a bunch of vertical asymptotes.
Yep. What we're doing, just as a quick reminder, so let's take sine, for example. You guys know that the sine function is this.
Yeah.
So inverse sine, you basically take it and flip it, like it goes vertically, and I'm not going to probably draw this perfect. Like that?
Yeah.
And so this is what I was saying earlier about it failing the vertical line test, so it's not a function unless we restrict the domain. So like on this one, we're restricting it just to that point, or to those points. So that's pi over 2 and negative pi over 2 for our outputs, and then our domain is just negative 1 to positive 1. Does that ring a bell? Did you guys study that? Okay. So tangent, if you think of it like you were saying, well, let's do that as dash. So pi over 2, negative pi over 2. Remember, it kind of does that repeatedly. So if we flip that on its side, I don't know if I can, probably can't draw that very good. Now we're going to have horizontal asymptotes, like that. But it's still the same idea as sine, so negative pi over 2 to pi over 2. What about the domain? Yeah, infinite. Good. Okay, so this is here, but we have to add the fact that these are not included, right? So negative pi over 2 is like, if you think about it as an open circle, or it's not part of the domain. It's not an or equal to situation. So those don't get included in the range. Same up here, pi over 2, open circle. Because that's where the cosine is 0, which makes this fundamental. All right, last stuff. The reason we reviewed that was because of this last bit on the back. These are super quick. These are like, to me, these are kind of back to like algebra 2 or geometry problems, with the exception of knowing your unit circle now. So arc sine of x, what is this actually asking? True.
What is the derivative?
Actually, these are not derivatives. So what is it asking us to find?
Just the x value at y.
Yeah, now you're on the right track.
So the x value at y equals 3, the square root of 3 over 2. Or is it?
Well, instead of saying x and y, maybe say angle versus value.
I guess.
Yeah, like what value would give sine equals square root of 3?
Yeah, so what angle, maybe we'll say it this way, sine of what angle gives root 3 over 2. That's what it's asking. So think of all your pi overs, right? What angle gives root 3 over 2?
Pi over 6.
No, actually, it is pi over 3.
Yeah.
It's pi over 3. Okay, that's all. Just being able to do that, though, without a calculator or a reference. So pi over 3. Okay, same idea here, cosine of what angle gives, what was it? Well, we have to plug that in. So negative 1/2. So remember negatives are in the second quadrant?
Yeah, so it would be square root of 2 or negative square root
It would be 3 pi over 4.
No, because pi over 4s are root 2 over 2s.
Oh, that's right. So it would be the one.
It would be negative 5 pi over 6.
It would be 2
That's-
pi over 3. 2 pi over 3.
There you go. 2 pi over 3.
Because it's 4 pi over 6.
Because it's this one right here,
Yeah. Okay.
right?
That's gonna.
So 1, 2, 3. I didn't draw that second one very good, but 1, 2, 3 thirds. Well, it's what you said. 4 pi over 6.
Because it's a 6 past pi over 2.
Yeah. Which I'll just leave it at that. Good old unit circle. And then tangent's even worse.
So that's
Wait, 1 over root.
that's the small one over the big one. So that means sine is smaller.
Yeah, so to get that, I think this is what you're saying.
Yeah.
Yeah,
That's
so
right.
it's pi over 6.
Good. Yeah, that's fun. We should have a unit circle quiz.
We should do like those, like, what are those, like, we used to do one in like elementary school, and it would be like, it would give you a bunch, like with the multiplication tables.
Oh,
you
yeah.
have to memorize all of them and do them as fast as you
Oh.
can.
Like a speed time, like a
We should do one
trial.
of those on this.
Good idea, I like that.
You're gonna fail so bad.
I don't know if it'd be faster to like go through each question and like draw a unit circle and then
Oh yeah, that's true.
we'd have to.
Because technically you only have like a minute for each question on the test. I mean, I guess that's.
I think it's a little longer than that. I have it written down someplace, I'll try to find it.
The quickest test I had to do was I think AP environmental science and it was like a big question.
Do you have to do calculations for that?
No.
It's just like knowledge questions?
Yeah, that was probably the easiest. Either that or AP human geography was the easiest AP test.
No.
Maybe test it too.
I think in environmental science, human geography, statistics, pre-calc.
Cool. So you're familiar. Did you take any other AP classes?
AP Spanish,
No way,
Calc
cool.
last year, and then I was supposed to take the AP Lang one, but they didn't have a test for me because I was gone the first day
Oh,
that they took it, and then they didn't realize that I was gone. So they didn't have a test for me on the makeup day, so I just had to just deal with it.
that's annoying.
Yeah.
So are you pretty close to fluent in Spanish?
I've been speaking it since kindergarten.
That's cool. Good
When I
job.
saw him in EP Spanish, I was like, what is this kid doing? And then I just hear him like speak Spanish. I'm like, oh.
So you took AP Spanish?
Yeah, we took it this year.
Oh, okay.
That one's the easiest class.
That's the
ever
easiest
taken
class
in
to
my
pass.
life.
Actually, that's not. That's
Well, I
not
mean,
true.
if you know Spanish, like it's easy.
Yeah.
Like, it was my first language, so it's like.
Yeah, that makes it easier.
It was the easiest AP class I've ever taken.
That's good. Is it mostly vocabulary or is it like grammar and writing?
It's mostly.
It's not even
It's
that.
not even that. It's
like,
just like so like the test consisted of like there was like an audio and you'd have to listen to audio and then you'd answer questions. You had to do a letter and then an essay, right?
yeah,
And then you had to have a conversation with like
with like
a
a
computer.
automated.
Like they had
thing.
like it's a person that says something and you just answer.
Kind of like Duolingo would be kind of?
Kinda.
Kind of, and then you have like a multiple choice question. And it's kind of like just like they give you like a passage, you read it, and then you answer questions. It's,
Then reading it in Spanish.
yeah, it's
And
like
then
all Spanish.
writing your essay in Spanish.
Yeah, but like they don't worry about like spelling or like grammar or like using like the correct like what's it called?
Yeah,
Like,
Accents
The
and
like
tenses.
stuff.
the accents and
Oh.
all that stuff. Yeah, like you didn't like they weren't worried about that. So it's like,
Really?
yeah.
Hmm.
Well, it's because it's AP Spanish, not AP like the other one. The other one that they don't teach here, but Mr. Finger's talking about is like AP. It's like Spanish. It's like the actual. How do I explain it? humor. It's like another like form of like.
Yeah.
It's like this one was more of like a. I don't even know how to explain it. It was like a literature, like Spanish literature.
Okay.
That's where like all that stuff goes.
Not in Spanish writing so
Yeah.
much. That's cool. Maybe you should take another
I
one.
should, well, I mean, Spanish is one person, which is,
Yeah, you should.
Oh, is it?
yeah.
Well, take it next year.
I think I should, I'm already planning on taking AP Physics, and then AP Computer Science.
AP Physics, you just have to use this stuff.
Yeah, physics is cool.
I was gonna take AP Physics with this class, but then they closed one of the AP Physics classes that I wanted to take, so then I switched that for senior English.
That was a good choice. Like they have more than one AP physics?
They had a 2-3 block, and then they had a 5-6.
Really?
And the 5-6 would work perfectly, but they closed that one because there wasn't enough people signing up for it.
Not closed it because it's full, but because it didn't have any.
Because they didn't have enough.
Okay. You'll like that class. Physics is cool. But yeah, so that would be if you took physics, Spanish, and computer science. What would that be, like 7 AP classes?
Well, now it depends. Because I want to take the AP. Is it AP Lang or AP Lit? AP Lang test, and then the AP Psychology test, and this one. So
So we're like 9?
it would be 8 or 9 counting the AP Lang.
That's a lot.
Or actually,
Will they take all the at Mines?
Yeah, they take. I think they take all of them.
I was at a tennis, the banquet, you guys, they always call it that, on Saturday with Miss Arledge's stepdaughter's mom. I don't know if that makes sense, but her and her husband hosted the party. So, but anyway, her daughter goes to to Mines and is studying chemical engineering, just like me. So I thought that was kind of a cool connection. I suppose if you ever had questions, I could help get you connected with that girl.
Yeah.
Her name's Taylor Arledge. You probably have heard her name.
his last name Arledge.
She's well, she graduated. She's a sophomore in college, so she graduated when you were a freshman, I think, and you were probably a sophomore. So yeah. Anyway, if you ever want to get connected, it might be good to have some inside scoop on that exact thing you want to do.
Yeah, that'd be cool.
Yeah. Anyway.
Guys, why haven't you taken AP Spanish?
My mom says it's going to be really hard.
Really?
Yeah, she said just like it's going to be hard to see.
No.
No. When I tell you, it's the easiest class ever. No, literally, okay, so I'm not like trying to, like, he's a cool teacher, like, cool person, but like, he would make us do work, but he never graded. He would just make us turn it in.
Yeah, that was the easiest class.
And then like our summative was like the AP, like it was like the mock exam. And so then like, well, you take the mock exam like a couple months before even school's over. So then like after that, like it wasn't like free time. Like you still give us work and stuff obviously, but like it was more laid back.
Yes.
Yeah. It's because mostly everybody in there like they already spoke Spanish. So.
Yeah.
So how did you start learning Spanish in kindergarten?
I went to DIA.
Oh, okay.
Yeah,
Cool.
for way to the reference.
My wife taught at a dual. It was not here in town, but she taught at a bilingual school, and they're cool. I think that model is really neat.
Yeah. My first year, I was like, I don't know what's happening.
What the heck? Yeah.
Yeah, honestly, learning